All right, day 10. I might have to break this video up into multiple videos because it's my dad's birthday today and I'm waiting on a phone call from the family, but it's kind of an indefinite amount of time that they weren't sure when they're going to be ready. So in the meantime, I thought I would start tackling day 10, just a heads up on that. But let's get started. Day 10, adapter array. Patched into the aircraft's data port, you discover weather forecasts of a massive tropical storm before you can figure out whether it will impact your vacation plans. However, your device suddenly turns off. Its battery's dead. You need to plug it in. There's only one problem. The charging outlet near your seat produces the wrong number of jolts. Always prepared, you make a list of all the joltage adapters in your bag. Each of your adapters is rated for specific output joltage. Your puzzle input, any given adapter can take 1, 2, or 3 jolts lower than its rating and still produce the rated joltage. In addition, your device has a built-in adapter rated for 3 jolts higher than the highest rated adapter in your bag. If the adapter list were 3, 9, and 6, your device's built-in adapter would be rated for 12. So that 3 is higher than the highest rated adapter, so 9 plus 3. Treat the charging outlet near your seat as having an effective joltage rating of 0. Since you have some time to kill, you might as well test all of your adapters. Wouldn't want to get to your resort and realize you can't even charge your device. If you use every adapter in your bag at once, what is the distribution of joltage differences between the charging outlet, the adapters, and your device? For example, suppose that in your bag you have adapters with the following ratings. With these adapters, your device's built-in adapter would be rated for 19 plus 3, 22 jolts, 3 higher than the highest rated adapter. So we're just sorting it to find the max, right? Because adapters can only connect to a source 1 to 3 jolts lower than its rating, in order to use every adapter, you need to choose them like this. Is this maybe going to be an ordering problem? The charging outlet has an effective rating of 0 jolts, so the only adapters that could connect to it directly would need to have a rating of 1, 2, or 3. So yeah, it needs to be 1 to 3 jolts lower. Of these, you only have 1, which is rated at 1 jolt here. So we don't have 2 or 3. From your 1 jolt adapter, the only choice is your 4 jolt rated adapter, difference of 3. Oh, I see. So we need to chain these together. So we have this 1. This 4 can connect to the 1. From the 4 jolt rated adapter, the adapters rated 5, 6, or 7 are valid choices because those are 1, 2, or 3 jolts above that. However, in order not to skip any adapters, you have to pick the one rated 5. So we can't skip any. The next choices would need to be the adapter rated 6 and then the adapter rated 7, because those differences are 1 and 1. The only adapter that works with the 7 one is the 10. From 10, the choices are 11 or 12. Okay, so we need to adapt the 0 switch, the 0 outlet to the maximum. Here's a larger example. In this larger example, in a chain that uses all of the adapters. Oh, we have to use all of them. Okay. There are 22 differences of 1 jolt and 10 differences of 3 jolts. Find a chain that uses all of your adapters to connect the charging outlet to your device's built-in adapter and count the joltage differences between the charging outlet, the adapters, and your device. What is the number of 1 jolt differences multiplied by the number of 3 jolt differences? Okay. So effectively, we need to sort these, start at the lowest, and then find the next lowest. I think we're assuming that all of these are valid. And then we just are looking at the differences between them. So it's kind of like the fence post problem, where we're counting the fence post. So we're counting the spaces in between these. There are 22 differences of 1 jolt and 10 differences of 3 jolts. Okay. So the first step in any of these problems is always to parse the input. So I'm going to create a new test class. Day 10. And then I'm just going to call it, I don't really have a good name for it yet, so I'm just going to call it day 10 test. And then here's our file, so day10.txt. And I think right now, I need to create a folder for this, and I think I'll pull down the full input as well, just to have it. Day 10, this here. Here's the full input. And now we're gonna let's just write a little algorithm for this, and then we can factor it into a class later. I don't even think we need a class. I think we just need a list of these in order. I mean, couldn't we just realistically just sort these? We could just sort this from smallest to largest and then count the number of basically count the fence posts, right? I don't think that it's really any more complicated than that. I'm sure that all of this complexity will come into play later in part 2, but for now I think we can just do a simple sort unless there's some detail that I'm missing. So we want to use that parse input method that we created for the test util in a previous video. Parse input, and then I'm going to pass in this class. And then day10.txt, and then our mapping function is going to be it.toInt okay, and this is just a Kotlin hanging closure, so really it's kind of a syntax thing where you can basically hang this closure off of here and just pass in your method in this closure, and then you pass in the parameters as normal function parameters right there. So you have the class, the file name, and then this closure at the end. So the input, basically we just want to do input.sort sorted, and then I don't know if there's there's probably a functional way to do this. But we could really what we could do is ideally we could just map it to the differences between it and the next highest number. It needs to know what the next thing is. I think we can do a map indexed. We have I. Is I the value, I assume, here? Okay, yeah, so I is the value. I'm just gonna go value here, and then I guess the trick is the number of fence posts is going to be 1 minus, or the n minus 1, right? Because there's n-1 spaces in between numbers. I might just need to do a for loop for this. I don't know if there's a clean way to do this in a functional style. So I'm just going to do for I in input.indices. I'm going to make a I'm going to actually, we want to sort this, and we want to start, I think I'm going to start at index 1, and then just append this map, or append to a list of like 3 minus 1. I'm not articulating this well, but I think what I'm going to do, like let's say I had like 1, 2, 3. What I'm going to do is, or like let's make these a little bit different. This will be like 1, 4, and 6, say. So what I'll do is start at this index, and then I'll create a list of I'm basically creating a list of the differences between the numbers. And so I'll start at index 1, and then I'll take index 1, take the value from that, and then subtract the previous index, and then work my way up the list doing that until I hit the very end. And then that way it'll handle the n-1 fence post case. So what I want to do is create a range of, I want I to be 1 in this case. I want it to start at 1. So I think I can just do, I can do it in line here. I in 1 to input indices. 1 to input indices. Or input dot size. There we go. And what I want to do is I'm going to have my, I'm just going to call them fence posts equals mutable list of nothing, of int, and then fence posts dot add, and then I'm going to subtract the value previously input at I, and then minus input at I-1. And then I just want to look at that. I want to count I actually want to count the number of 1 jolt differences multiplied by the number of 3 jolt. So I'm going to say 1 jolts, val 1 jolts is equal to fence posts dot, we want to filter these by it equals 1, and then we also want to filter by, we'll call it 3 jolts, and then it equals 3. And we just want to make sure that, let's just double check that this is working. We also want input sorted first. So we need to, I'm going to stop this test because that's kind of a critical piece of this, is that the input needs to be sorted. I think I can just do this here, sorted. There we go. And I want to make sure that it's sorted by smallest to largest by default. I think that is the default. Returns a list of all elements sorted according to their natural sort order. So let's double check. Input. That's not what we expect. Input is size 0. Oh, I didn't paste anything in here, that's why. Oh, I pasted it in full, whoops. Here's the full one that we want. Okay. So my input is 31, and then it's sorted. Okay. And then the 1 jolt differences, doesn't like that, huh? Array out of bounds. 31 is out of bounds for length 31. I'm going to say until input.size, which is, that'll give me an exclusive, excluding the 2 value. There we go. And then the number of 1 jolts should be 10. And our fence posts are, it's a lot of 1 and 3s here. Yeah, so that's what we expect. 1 jolts is interesting. There are 22 differences of 1 jolt. And 10 differences of 3 jolts. What did we do wrong? So the fence post should be 30. Yeah, it's n minus 1. How are we on our 3 jolts? This should be 21. $20, 22, is that it? Let's take a look at this here with both of these 1 jolts and 3 jolts. 3 jolts is 9, so we're getting, in this larger example, in a chain that uses all of the adapters, there should be 22 differences of 1 jolt and 10 differences of 3 jolts. It's odd that we're off by 1. But this input size should be 31. Did I paste this in correctly? Starts at 28, ends at 3, yeah. That's 31. So we would expect 30 fence posts. It's odd that this adds, in this larger example, am I reasoning about this correctly? Oh, I guess we need to count the initial one, right? There's that initial one from 0 to 1. So I do need to add so there's kind of an implicit 0 here. So I'm going to make a val sanitized. I'm going to make this called joltages, and then that's going to be input.toMutable map, or to immutable list, and then I'm going to add joltages.add 0. Add the wall adapter. And then is there, so does it tell us, do we have a, I wonder if there's also, is there something that we need to factor in for your device too? Because I noticed my 3 jolts was off. Oh, finally your built-in adapter is always 3 higher. Okay. Okay. That's why. That's what we were missing here. Add 0. And then we also want to do joltages.add joltages.max. Max or null, but we know that there's always going to be. And then we want to do +3. Add the wall adapter and your device. I think I'm going to make up, just to reduce mutability here, I am going to do parse joltages as a private function. And then this is going to return I'm going to have a method, or an input file name as a string, and then this is going to return a list of int. So we're going to get this. Input is this file name here. And then we're going to return joltages, and we want to do it sorted. Sorted. And then to list. This will give us an immutable list. Day10.txt. One jolt size should be 22. 3 jolt size should be 10, I think. All right. Okay, and then what is the number multiplied by the number of 3 jolt? So then that's just going to be 22 times 10. So this should be, oops, I don't want to debug this. I just want to okay, so that's correct now that we've factored in the wall adapter and the device. So now I'm going to do my full part 1 input. We're going to parse the day1 full.txt, and then we want to print ln 1 jolts.size times 3 jolts.size. $1,700. That's the right answer. I think I'm going to split this video into 2 parts, just because I'm expecting a call from my family at any point, and if I get interrupted in the midway through part 2, then I can just refilm it afterwards. So I will see you in part 2.